Welcome to South Jose's campus. I am Hugo Sobczyk, a member of the Astor Kids and the correspondent for South America of the SIAE. Today I'm standing in front of the PIT. It's the innovation hub of South Jose's campus, and it's the biggest one for space. Here are working over 150 different companies to make innovation in space. In the next 3 days, there will be a fair about agriculture in space. And in this fair, we'll speak about why do we need agriculture in space? What are the difficulties? And how far away are we from real traveling in space? And today I'm taking you on a journey about agriculture in space, the SIAE. But what exactly does that mean? It's the First International Symposium on space farming, and we're waiting them to begin. Today they're meeting speakers of different companies and universities to discuss the challenges and solutions on space farming and different other topics. So let's see what's happening.
It's a great pleasure to welcome you to Brazil. I hope we can find ways to cooperate, since the lunar endeavor that we are facing will not be possible without international cooperation. So I wish you a productive symposium and building the networks that we need to foster a space farming for the future of lunar exploration. Thank you very much.
One of the biggest highlights was Ivanir Condijo. He is one of the physicists of NASA and helped immensely on some missions to Mars, like the rover Perseverance. In his presentation, he showed a bit of his work, like how to get to Mars or what are the biggest problems to get to Mars. It was a bit general because it was one of the first presentations of the day. But in the end, I could even get him for a short interview. Did the Mars had enough time to form any life forms?
Again, Mars differentiated from Earth very early on. So about 3.5 billion years ago, it was already more or less what it is today. So there was very little time from the time the planets were formed, 4.5 billion years ago, to the time when it differentiated, so maybe about 1 billion years. But on Earth, life formed very early on. About 400 million years after the planet formed, we already had life on Earth. Perhaps the same thing happened on Mars. We don't know. And so these missions, one of the objectives is to find out whether life formed there or not.
At the conference, there were some other big personalities too. I guess I interviewed all of them. But yeah, one of the biggest one was like James Green, the former chief scientist of NASA. Or Anderson da Silva, the director of INFI. That's practically the Brazilian NASA.
So Mars had a magnetosphere, okay? And as you have volcanic material, molten rock, come to the surface. During the time Mars has a magnetosphere that is generating it itself.
Yeah.
Then the rock cools, right? It becomes a matrix of material.
Yeah.
We call that a basaltic rock. Okay?
Yeah.
But what happens is a lot of that material, which is a high mass material like iron, magnesium, a number of things that now are coming up from interior, it has these atoms have a net magnetic moment because the electrons are spinning around, everything's spinning. So actually you can measure the magnetic moment of an atom. Now that means as the rock cools, the magnetic moment of these atoms all line up. They're not random like they would be as the rock would cool on a surface without a magnetic field. And then the field goes away, but the magnetic moments in the rock generate a net magnetic field, okay? And we call that a remnant field.
You know, the main problem, in my view, it's the time that it takes from the Earth to go to the Mars and come back. So we are talking about more than 2 years, 3 years, or something like this. So it's a very long time that is much more complex and different that was to go to the moon. That you can go in few days, stay some time there and come back. This is in my opinion, the big challenge that the humans will have, how to survive in very hostile environment
For a very long time.
very long time. So, and there is a lot of missing technology that will ensure this. We still don't have all the technology that is required.
Today is the second day. Yesterday we spoke about Mars terraforming, what are the problems, have we solutions, how to live in space. And today we're going a bit deeper. It's the main day and we're speaking about real agriculture in space, how agriculture works in microgravity or how to get plants to Mars. And I hope you'll enjoy. The second day was a bit more technical. There were more international guests, like persons from the Italian Space Agency or an astronaut from the University of Florida. One of the professors was Professor Paulo Rodriguez. And now I'll give you a little taste of what exactly he's studying.
Yes, yes. This is a clinostate, yeah, and the clinostate simulates the microgravity environment, okay? And here in this equipment, work to get a CubeSat. The center of the clinostate, we have the CubeSat. CubeSat is a nanosatellite, yeah, 10, 10, 10, the dimensions, yeah. And we adapt in this clinostate because we can figure out how the plants run in the microgravity environment. Okay, this equipment is analog. If I send the more cheap, if you send it to the space in ISS, yeah, and the results is very interesting because we can evaluate the grow conditions and the light spectra too, because the plants respond different in each kind of light spectra.
Language. Every time I hear the expression Mars sample return, I say, well, the sample is not returning to Earth. It's the first time it's coming here. No, Mars sample return means you get the sample, bring it to Earth, and then take it back to Mars, and then returning the sample. But anyway, maybe in English it makes sense.
English is my second language, so it's also a mistake.
Okay, we have questions here. Finally, we have a panel working very, digital interaction. So let's go to the first one.
The dimension, they also used Slido, of course. Today is the third day of the symposium. And yesterday we spoke about the plants, how they react to radiation, how they react to go into space, how the genes are activating in space, how it is helping with agriculture in space. And finally, as a highlight of the day, we watched The Martian from Matt Damon and Ridley Scott. It was commented by James Green. He was the one who made the whole film that realistic. Today we're speaking about microbacteria and microorganisms and how they could help us in agriculture in space. The third day was significantly shorter. But, however, there was a highlight. Now I'll show you a short clip from my interview of Professor Pohl from the University of Florida. She was the first who has ever experienced planting some plants on moon soil. Your other experiment with the moon dust and the moon soil.
Yes.
How was the feeling to plant something like this?
It's amazing. And even when I've talked about this in very different kinds of ways now many times, but even standing up here just a half an hour ago, I could feel it in my chest, right? I could feel that emotion because, so it takes Arabidopsis a couple of days to germinate. And so Rob and I did all those plantings, and because we had to kind of keep it secret from, NASA made us keep it secret until we actually published it. And so we couldn't bring in the normal number of students and postdocs and things to do this work. And so Rob and I did a lot of that work ourselves. I mean, the putting it all together and stuff. That we had some help, but it was, but we were very invested in it from just personally. And so we got all those things planted, and we put them in the growth room, and we had a special locked room and everything that we had to grow them in. And it's like, okay, they're not going to germinate for at least 3 days, so we should just chill and not go in there. But of course we couldn't do that. And so on day 2, we went in there, and they were already starting to germinate on day 2. And when we walked in there and saw just a sea of these little tiny green seedlings, it really just brought tears to our eyes, because you think about this is the first time that terrestrial life has grown in an extraterrestrial material, and we're seeing it. We are the first humans to see this, and it was really emotional, and it was also emotional thinking that kind of part of, small part, but of history, right? That this is, anytime you have the privilege to do something like that, it's a real honor to be part of that history, and it sort of struck us all at once at that moment in a very strong way.
Short before the ending of the event, there was a little raffle. You could win something like a cab or a book or a dinner in a restaurant. And why not? I won. I won a book about sweet potatoes. And that's a little insider, because sweet potatoes were chosen to be one of the species who would be growing in space, because they have a lot of these nutrient stuff. After the ending of the first SIAE, we got to a journey through the INPE, the NASA of Brazil. But your journey did not even start yet. So come with me through all the other interviews I made. We see us in the next interview.